Welcome to MrCScience.com's video on atoms and molecules. We're going to talk a little bit about atoms and molecules and then do the experiment out of the book. So, atoms and molecules. What is an atom? According to your book, an atom is the smallest chemical unit of matter. Now, normally I say do these definitions in your own words. These are kind of the best words you can use and the shortest. The main thing here is chemical. It isn't the smallest unit of matter. You can break an atom down into smaller pieces of matter, protons, electrons, neutrons, quarks, things like that. They all have mass. They're all interacting with gravity, so they are matter. But chemical, they're the smallest unit of matter that's still chemically itself. So if you take, we're going to work with some copper wire. If you take copper and you divide it into pieces, you can keep dividing it into pieces, and each piece is still copper until you get down to an atom. One atom is copper, but if you divide it then it's not. So an atom is the smallest chemical unit of matter. It has its own properties. Keller, conductivity for metals, luster, things like that, mass. Molecules are collections of atoms that bind together and change the properties of the atoms. So what we're going to do in our experiment today is we're going to change the properties of the copper atoms and see some changes. Okay, what we're going to do today is we're going to do a little experiment. We've got a battery. I've attached some wires to it. These wires are copper. You see the brownish color right there on the copper wire. So copper is brown, kind of shiny. You can see the luster there. You can see a little bit of the color. We're going to add some baking soda into our beaker and run some electricity through it, and we're going to change the atoms. Okay, this is the first lab we're going to do for the year, so let's talk about how we're going to write up labs. We write up labs like you would in college or if you were actually doing the science on your own. Not quite as detailed and technical as that, but same general layout. So what you'll need is a sheet of paper for your lab or a lab notebook, something different. Depending if you're in my class, I collect your lab notebooks. If you're not in class, then on the website I'll have how to get those labs into me. So go ahead and get your sheet of paper or your lab. If you're just sending them in, maybe you want to do electronic as well. So it's up to you. Okay, so what we're going to do is on the first line of your sheet or your new page on your lab notebook, we're going to put in Roman numeral number 1, Roman numeral number 1, period, and title, colon. You should write it up just like this, Roman numeral 1, period, capital T on title, and colon. Every lab should have a title. So the title of this lab is Atoms and, here I'm going to use the and sign, and molecules. Okay. On the second line of the lab, we're going to do Roman numeral number 2, and we're going to give it a purpose. Every lab has a purpose. By the way, if I'm going through this too fast with you, one of the nice things about video is you can pause the video, catch up, and then start it again. So, okay, the purposes of this lab is to change some atoms into molecules. Okay, and we'll talk about atoms and molecules as we go through the lab. Roman numeral number 3, hypothesis. A hypothesis is an educated guess. What do you think is going to happen in this lab? Most of the time I'll generate their hypothesis for you, but every once in a while I'll ask you to help or to do it. Hypothesis in this lab is molecules have different properties than the atoms they are made up of. So molecules have different properties than the atoms that they are made up of. Okay. Next one, next line, Roman numeral number 4, materials. These are the items we use in the lab, so everything from the beakers to the chemicals, batteries and wires in this case, a spoon. You want to write this up as completely and as in-depth as possible so that if you discover something interesting, you can give this to a colleague and he can reproduce your lab exactly. For this class, we're not going to waste a lot of time in this. This is something that if you're doing real science and this is real science, but if we're doing real experiments trying to find something new, then we do that. Most of the time we're going to use here when the lab is from the book is as per text. Okay, next line, Roman numeral number 5, procedure. This, like the materials, is a very detailed and complete list of exactly how we're going to carry out the lab so that if someone has to reproduce it, they can do it exactly like you did it, thus reducing the experimental variables and being more likely to reach the same results that your lab reached. Again, we're not going to waste a lot of time in class doing that as well because we're just going to, most of the time, as per text, what's in our textbook. Next line, Roman numeral number 6, observations. This is where the magic happens. Here's where we carry out the lab and we record any observations or data we get from the lab. We don't analyze the data at this point, but we just record it. So you're at this point, so we're ready to start recording observations from our lab. First observation. If we look at our wire, let's see if we can get a decent picture of it here. Webcam's not great at really close shots, but you're familiar with copper. Guess what color copper is? It's kind of a brownish color. You'll notice it's kind of shiny and has luster. So we're going to record a couple of the properties of copper. So let's go back to your lab and let's see. Copper is brown and has luster. That's a science way of saying shiny. So, okay, copper is brown and has luster. Okay, so let's go on to our experiment now. Let's carry it out. So, what we want to do is we want to. We've got just some tap water here. We don't need distilled water or anything fancy for this. Tap water. We got baking soda. What we're going to do is we're going to add a teaspoon or a spoonful of baking soda to our water and stir it up. Notice the water becomes white. Guess why? Because baking soda is white. Some of it dissolves. We probably added more than will dissolve, so our water will be kind of whitish. Just want to stir it up good, make sure it's all nice and dissolved. Okay, there we go. Now it's clearing off a little bit. You can see in the middle. And we got some on the bottom that didn't dissolve. Okay, cool. So now what we're going to do is we're going to take our wires and we're going to put them in the water. Only do this with a battery. We do not do this with an outlet. That would be extremely dangerous, and you'd probably have to find a new science teacher if we did that. So we just put them in the water. There we go. Okay. So now let's see if we can get a good shot of this. Let's get a little bit closer. There we go. Now you can see, first thing you see, bubbles coming off of the wires. So you can see bubbles really well here. Not bubbling as hard on the other side, but both wires are bubbling. So we got both wires bubbling. That's our next observation. So let's go back to the lab. I wish I could focus that a little bit better. If we back off just a little bit. That's not too bad, but you can see the bubbles right here. See some bubbles right there. Okay. So go back to our lab notebook. And our next observations. Wires bubbled when placed in baking soda solution. So we created a baking soda solution. The wires bubbled when we placed them in there. Okay, now bubbling can be one of two things. It can be a state change. It can be going from a liquid to a gas, but generally that takes heat. And I'll tell you, these wires aren't heating up at all. The thing's not heating, so we're not boiling the water. So something else is occurring. State change is often a sign of a chemical reaction occurring. So I can tell you, we'll do this in another lab later on, that what we'll find out is that off of one of these wires, oxygen is coming off, and off the other wire, hydrogen is coming off. Well, guess what water is made out of? Hydrogen and oxygen. So we're tearing apart the hydrogen and the oxygen. There is a chemical reaction change in there. We're taking the atoms of water, or the molecules of water, and changing them into atoms of hydrogen and oxygen. So we got a chemical reaction occurring. That's a sign of a chemical reaction. Another sign of chemical reaction we're going to be looking for is color change. So change in color. Oh, we see a little wisp of something coming off there as well. Okay, so yeah, right on the edges there we see kind of interesting. Let's see, I don't know that I can focus this any better. Okay, so what's going to happen is we're going to let this sit for a little bit. Now, one of the mysteries or wonders of video is that you don't have to sit here and watch the entire thing. I'm not going to do a time lapse. I'm just going to stop it for a little bit, then I'll restart it, and we'll see if any changes have occurred. Okay, I did a couple things. I put the one wire in a little bit further, and I also added a sheet of paper underneath because we're seeing something else right now. It's more visible to me than over the web camera, but with the sheet of paper there, you should see that you're starting to see a blue color in the water. So that's our next observation. The water is turning blue. Let's go over to our lab notebook and add our next observation. Water turning blue. Again, we don't say why or anything. We just record what we see. Okay, so we're going here. I'm going to let it go a little bit longer. Then we're going to, maybe we should take a look at the wires right now just for the fun of it. So let's pull the wires out. Now, one thing you might notice right off the bat is what's the bottom of this wire look like? It's all black. So one wire is turning black. The other one, can we see it? Not yet. It's got to be in there. I'm starting to see a little that same blue color on the other wire. So let's put the wires back in. There we go. Okay, so let's go back and record that as an observation. One wire turning black. Now I said that state change, going from a liquid to a gas, is a sign of a chemical reaction. Color change is also a sign of a chemical reaction. Something's happened to the chemicals to make them absorb and reflect different wavelengths of light than they were before. So, kind of interesting. So now you're starting to see the blue color a little bit better. I'm going to pause the video again for a little bit, and we'll see if we can see even more major change. Okay, now we're starting to see quite a good blue. It's even coming through on the webcam, which is nice. So we're seeing that blue color. That blue color we're talking about is a chemical called copper hydroxycarbonate. So it's a combination of the some molecules in the baking soda along with the copper. You'll read in your book, why is the Statue of Liberty green or a bluish green? Well, it's because it's copper. And it's reacted to the salt water in the air, and it relatively quickly turned into the color it is now, and that coating is copper hydroxycarbonate. We'll talk more about that in the conclusion. Let's give it just a little bit longer. Okay, so now we're really blue. Let's go ahead and remove the wires and take a look at the wires. So I'm going to take the wires out of solution here, and I'm going to lay it down. This one's really black. It's got a lot of charcoal on it. I'm wondering if you can see the blue color here. It's not really coming through. Yeah, you can't even get close. I don't think it'll focus.
Put your hand on it.
A little bit. It's trying to focus. And everyone's talking. Let's see, okay, well, this wire's got a kind of a blue-green color, kind of like the Statue of Liberty. If we leave it there for a long time, we might be able to get it more blue, but our water is definitely turning blue as some of that copper hydroxycarbonate goes into the solution. So let's go ahead and add our last observation. So we're going to add other wire, turn blue, green. Okay, good. So now we've got our observations down. Now comes the most important part of the lab. Roman numeral number 7, conclusion. Why is it the most important part of the lab? Because if you forget it, it's worth half the lab, so you lose 50% of your lab. So, what we do in our conclusions, we restate what happened, and analyze the data, and talk about our hypothesis. So, restate what happened. When the wires were put in the solution, it generated bubbles and changed color. Both are signs of a chemical reaction. Okay. So that's kind of what happened there. Our hypothesis: molecules have different properties than the atoms they're made up of. The copper atoms combined with atoms in the baking soda solution, making new molecules. These molecules had different properties than the original atoms and molecules. That's showing that our hypothesis was correct, that molecules have different properties than the atoms they're made up of. So our hypothesis was correct. Okay. If you copied everything down exactly like I put it on here, you just got your first 100% on a lab in the class. So hey, good for you, good start. So if you have any questions or concerns about this, always feel free to drop me a line at Mr. C at MrCScience.com. Thanks.